In a previous video, we talked about some AWS account security best practices, and some of those included IAM strategies. But there are a few more strategies pertaining to IAM that I'd like to talk about in this video. So, in this video, we're going to talk about more IAM guidelines and best practices. First of all, you should create groups that reflect organizational roles, not technical commonality. So, two users that require the same technical permissions to perform two different roles in an organization should be assigned to two different groups based on their roles rather than a single group based on the technical permission. The reason for that is that the function of the roles will likely change over time, requiring different technical permissions. If the users are grouped by role, the permission changes can be highly targeted to the changing role, reducing the risk of inadvertently granting new privileges to extra users. For example, a data warehouse admin and a data scientist might both need the ability to launch an Amazon Redshift cluster. In time, the organization decides to move their analytics from Amazon Redshift to Amazon Elastic MapReduce. If both employees were mapped to a group called Launch Redshift Cluster, then the IAM administrator would have to either A, increase the permissions of all the users in the group, or B, break the group in two and reassign the users manually, which introduces the risk of manual error. By contrast, with two groups, the IAM administrator simply removes the Amazon Redshift privilege from the data scientist group and adds the Amazon EMR privilege. The data warehouse admin group remains unchanged. The latter option decreases overall effort, minimizes the blast radius of the change, and reduces risk of human error. You should also have a documented process for removing unnecessary users and credentials, ideally using your groups. You should know what steps are required to remove a user and write them down. Ideally, you could also write a script to reduce that chance of error. You should also enable multi-factor authentication, at least for privileged users. Use MFA to lock down administrative accounts. Multi-factor authentication adds something called a something you have factor instead of the something you know factor of authentication, reducing the risk of a security breach. And if you were to go to users and find any user, then you can go to security credentials, find assigned MFA device, and then assign one using manage. My personal favorite is a virtual MFA device that I have installed on my mobile phone. You should also rotate credentials regularly. Credentials are secrets, and the longer a secret exists, the more likely it is to be compromised. Rotating credentials regularly helps mitigate this risk. Additionally, you should use managed policies rather than group or user policies. Although IAM policies can be directly associated with a user or group, use the newer capability of managed policies. Managed policies are reusable because they are decoupled from groups, making it easier to achieve technical commonality across different roles without misusing groups. Next, you should make policies granular. So you should add privileges to a group using multiple granular policies rather than one giant policy. For example, a data scientist might need access to Amazon Simple Storage Service to upload raw data and also to Amazon EMR to launch clusters. You should create a managed policy for S3 and a separate managed policy for Amazon EMR rather than combining the privileges into a single policy. This will help promote policy reuse and make it easier to maintain permissions. Next, when it comes to credentials on EC2 instances, you should use EC2 roles rather than access keys. An access key is a secret and must be stored in a location that is secure but also can be easily referenced during the bootstrap process. Once acquired, the key must be securely stored on the EC2 instance yet retrievable in order to access AWS resources. These conflicts can create a perpetual risk in the DevOps process, a problem only exacerbated by the need to regularly rotate keys. EC2 roles eliminate the need for an access key, and the underlying technology of temporary security tokens eliminates the need for key rotation. Next, you should use roles rather than user credentials to grant cross-account access. The safest and easiest way to grant access to users in different AWS accounts is to create a role with specific privileges and grant other accounts the right to assume that role. The administrator for the other account can then allow specific IAM users to switch to the role as necessary to use its permissions on a temporary basis. Using roles eliminates the responsibility of creating, managing, rotating, and securely delivering access keys for individual users from different accounts. For example, if I wanted to allow a user from account 111111, then I would simply choose another AWS account as the trusted entity for a new role, and then assign any permissions I need to from the list of managed permissions. And finally, you should use conditions to make policies more granular. IAM conditions provide a wealth of possibilities to refine policies. These include locking down administrator accounts to only work from a specific IP address range, limiting developer permissions to specific subnets, granting a permission for a specific time window, and much more. You should learn the various conditions available and leverage them to create better policies. Now I'd like to end this video by talking about a few best policies specifically for creating users and groups. First, you should identify the first person to be granted access to AWS infrastructure and explicitly state any associated business roles for that person. These business roles should be very granular, and a person can fulfill several business roles. Next, we've said it before, but you should create an IAM group for each business role. Also, identify the AWS permissions required to fulfill the tasks of each business role. Create managed policies for each task and assign them to the appropriate group. And finally, you should create an IAM user for the person and assign it to the groups representing the appropriate business roles. Assign a username and password to the account. If this person needs to use the CLI or other tools to access the AWS environment, create an access key as well. And that'll wrap it up for this video on IAM best practices. I hope it was helpful, and if everything was clear, then feel free to move on.